Salam Jami'an, we are going to solve today simple exercises about complex numbers. We'll start with exercise number 1. Write in the algebraic form. Algebraic form, it means z equal x plus iy. Write each of the following complex number in the algebraic form. The first complex number, z equal radical 3 minus I over I radical 3. We learned in class that we have to multiply by the conjugate of the denominator, which is, here we can multiply by minus I or minus I radical 3, and we will obtain, minus I radical 3 works and minus I works, okay? If you did multiply, you will obtain minus I radical 3 plus I square, which is minus 1, over minus I square, which is 1 radical 3. So I can obtain minus I radical 3 minus 1 over radical 3. If I have to write it in the complex form, I can write it as minus 1 radical 3 minus I radical 3 over radical 3 minus I. And this is the algebraic form of this complex number. But do I have to do all this? أكيد لا. Why? Z equal radical 3 minus I over I radical 3. I can write it on calculator, mod, complex, I put a fraction, radical 3 minus I over I radical 3, and I can get the answer. It's minus radical 3 over 3 minus I. It's the same answer, only they did rationalize 1 over radical 3. I kept it minus 1 over radical 3, or I kept it as minus 1 over radical 3. Part 2, 1 z equal 1 plus I over 1 minus I. If I have to write it in the complex form, I maybe should multiply by the conjugate of the denominator, which is 1 plus I, 1 plus I. Then I have to expand and reduce. But also there is an easier way. I can only write it on calculator, 1 plus I over 1 minus I. Equal, the answer is equal to I, and that's it. Part 3. Z equal 1 minus I power 5. If you try to calculate 1 minus I on calculator, it wouldn't give you an answer. It gave you an answer, so you can write it as minus 4 plus 4I. I thought it's only calculate complex number to power 3. Anyway, if you want to do it in another method, or maybe if you have to do 1 plus I power 10, 1 minus I power 10, for example, in another question. I don't think the calculator can calculate 1 minus I power 10. It does. Power 20. Well, as I remember, the calculator does not calculate complex numbers with powers greater than 3. Maybe this one does, because maybe it's on computer. But if I have 1 minus I power 10 and I need to do it without calculator, I can say it's 1 minus I power 2 all power 5. If I did calculate 1 minus I power 2 as a remarkable identity, or on calculator, I will obtain minus 2I power 5, sorry. Minus 2 power 5 is minus 32. I power 5 is I square power 2 times I. It's I power 4 times I. I square minus 1 power 2 is 1 times I is I, so the answer is minus 32I. Part 4. Part 4. Z equal I plus I square plus I power 3 plus I power 4 plus I power 5. If I have to calculate, write this number as algebraic form. I is I square is minus 1. I power 3 is I square times I power 4 is I square I square. I power 5 is I power 4, which is I square times I. So it's I minus 1, I square minus 1 times I minus I square minus 1 square plus 1, I square minus 1 square plus 1 times I plus I. So plus I minus 1 plus 1, and the answer is I. This is the solution of exercise number 1. Question number 2. Solve in C each of the following. C is the set of complex numbers. Okay, z cube plus z equal to 0. Z cube plus z equal to 0. I can take z as a common factor. It's z square plus 1 equal to 0. A product of factors equal to 0 if and only if one of them, at least one of them, equal to 0. So z equal to 0 or z square plus 1 equal to 0. That gives us z square equal minus 1, which is I square. So z equal I or z equal minus I. So we have three solutions: z equal 0, z equal I, or z equal minus I. Part 2. 3z minus 2iz equal I. I can take z as a common factor. 3 minus 2I equal I. Then z equal I over 3 minus 2I. I have to write the answer as in the algebraic form. I can either multiply by the conjugate of the denominator, or I can find it on calculator. It's I over 3 minus 2I, and the answer is minus 2 over 13 plus 2I over 13, and this is the solution of this equation. Part 3. 3 over 13. Part 3. 2z minus 3z bar equal 1 minus I. Any equation with z and z bar should be solved by replacing z and z bar by their algebraic form. So z, as we say in the beginning, it's x plus iy. So in this case, z bar equal x minus iy equals 1 minus I. I should expand 2x plus 2iy minus 3x plus 3iy equal 1 minus I. The real part to the left is 2x minus 3x is minus x. This is the real part to the left. 2iy plus 3iy, 5iy equal 1 minus I. So two complex numbers are equal if real part is equal to real part. Minus x equal 1. Then x equal minus 1. And imaginary part is equal to imaginary part. So 5y equal minus 1. 5y equal minus 1. So y equal minus 1 over 5. Z equal x plus iy. So minus 1 over 5i. This is the solution of this equation. Any equation with z and z bar included in it must be solved by replacing z by x plus iy and z bar by x minus iy. Well, in other cases, I can either factorize or solving in a normal way, as I solve sometimes first degree equation or second degree equation. It depends on the equation itself. Now exercise number 3. Be the point of f x z in the xy x plus iy, and there is no function f from t to c. Z prime, and z prime is a relation between, is a complex number in terms of z. Z prime equal z minus 1 into z bar plus 1. Part 1. Find z prime if z equal I. Z prime if z equal I. You just replace z by I. But as you know, if z equal I, so z bar equal minus I. Okay? Z equal I, this means that z bar equal minus I. We just replace z and z bar by its value. I can either expand or I can find the answer using calculator. It's I minus 1 into I minus 1 into minus I plus 1, and you can find the answer. It's 2I. This is a particular case. You found the z prime if z equal I. You can't use it in the rest of the exercises. In the case if z equal I, you found a z prime. You can't use this value in the other parts of the exercise. Part 2. Find the set of points M in each of the following cases. هيدا الكويشن المفروض يكون في قبله find a real part of z prime and imaginary part of z prime in terms of x and y. هاي المفروض يكون قبل هون. So z prime equal x plus iy minus 1 into z bar, it's x minus iy plus 1. I should expand x squared minus I xy plus x plus I xy minus I squared y squared plus y squared plus iy minus x plus iy minus 1. So it's equal to x squared plus y squared minus ix plus ix plus x minus x, they vanish, minus 1, and iy plus iy 2iy. So this is the real part of z prime, and this is the without I, the imaginary part of z prime. Okay, you must ask this question before start saying find the set of points M if z prime is real. So z prime is real, it means that imaginary part of z prime equal to 0. Imaginary of z prime is 2y equal to 0, then y equals 0 divided by 2, 0. In this case, the variable y is always 0. Which line does we know exactly who has an equation y equal to 0 is the x-axis. So m moves, we can say m moves on the line d of equation y equal to 0, or we can say m moves on the x-axis. Why m moves on the x-axis? Because y is always 0 and y equal to 0 is the equation of the x-axis. Now part B. Part B, find the set of M if z prime is pure imaginary. Pure imaginary. Z prime is pure imaginary. We said in the explanation of the chapter a number is pure imaginary if a real part of z prime equal to 0 and imaginary part of z prime not equal to 0. A number is pure imaginary if real part equal to 0. There is two conditions. Real part equal to 0, so it's x squared plus y squared minus 1 equal to 0. And imaginary not equal to 0, it means that 2y not equal to 0, so y not equal to 0. So x squared plus y squared minus 1 may be an equation of a circle. On a draft paper, I will solve minus 2a equal. We explained before how to find the center and radius of a circle. This is the equation. Minus 2a equal coefficient of x. There is no x, so a equal to 0. Minus 2b equal coefficient of y. There is no y, power 1, so b equal to 0. So the center I will be maybe 0, 0, or will be the origin. R squared has a formula is a squared plus b squared minus c. It's 0 plus 0 minus 1 equal 1. So r equal radical of 1, which is 1. So you found the center, you found the radius, so of course it's a circle. But you notice that y should be not equal to 0. So as you know, m will moves L will moves on a circle LM will move on a circle C of center O and radius 1, but M should not move on the line y equal to 0, which is the x-axis. So M cannot be here and cannot be here. It moves on the circle, but it can't be on the y and the x-axis, since y not equal to 0 and y equal to 0 is the equation of the x-axis. So we'll say M moves on the circle C on the circle C of center I 0 0, or we can say O 0 0, and radius equal 1, and moves on the circle but not on these points, deprived of the points. This is the first point of intersection of the circle with the x-axis, A minus 1 0 and B 1 0. You will ask how you did find the coordinates of A and B. I found it here graphically, but if not every time you can find these coordinates graphically. So what you have to do, you will put a system or set up a system, equation of the circle and equation of the straight line, equation of this circle and equation of the straight line. This kind of system is always has to be solved by substitution. You substitute y by 0 in the first equation, you will obtain x squared plus 0 minus 1 equal to 0, x squared equal to 1, so x equal to 1 or x equal to minus 1. This is the point B 1 0 and this is the point A minus 1 0. But you don't have to show your work. Yani, this work is done on a draft paper. Only you have to say what is written here. Moves on a circle C of center and radius deprived of the points. You find the point, you find the center, and you find the radius on a draft paper. Now we still have only one exercise of the homework, of the worksheet, which is exercise number 5. No, 4 and 5. We still have 2. Exercise number 4 is very important. Is a very important exercise. Let's just start with given the complex plane, the point M of f(x) z equal x plus iy m prime, if the point of f(x) z prime, as always we'll have a relation between z prime and z. Z prime is another complex number. Z is a complex number and z prime is another complex number that has the relation with that 2iz plus 1 over z minus 1. It's been written that z not equal to 0. It's very important because you know that the denominator should be always not equal to 0. Z minus 1 not equal to 0, so that z not equal to 1. Part 1. Determine real part and imaginary part of z prime in terms of x and y. Z prime, when he asks this question, you should replace z by x plus iy plus 1 over x plus iy minus 1. I will expand in the denominator 2ix plus 2i square y minus 2y. You know, always we have to replace I square by minus 1 plus 1 over, and we should organize the denominator as real part then imaginary part. Why we should do that? Because to write this complex number in the algebraic form, you must multiply by the conjugate of the denominator, which is x minus 1 minus iy, x minus 1 minus iy. You should multiply by the conjugate of the denominator in the numerator and the denominator. And we have to expand. In the denominator we have a plus b into a minus b, so it's always a square minus b square, but because we have I square, it will be plus y square, so it's always real part square plus imaginary part square. And then we have to expand. the numerator 2ix square minus 2ix minus 2I square xy plus 2xy minus 2yx plus 2y plus 2I y square minus plus x minus 1 minus iy. So we have to reduce the terms. The denominator is x minus 1 square plus y square in both in the real part and in the imaginary part. The denominator is the same. Real part 2xy minus 2xy vanish, 2y plus x minus 1. Imaginary part we can say 2x square plus 2y square minus 2x and minus y. This is the imaginary part. Okay, so this is the real part of z prime, or sometimes they call it as x prime, and this is the imaginary part of z prime. Part 2. Find the set of points m in each of the following cases. Z prime is real. Z prime is real when imaginary part of z prime equals to 0. So this fraction, this is imaginary part of z prime equal to 0 when the numerator, a fraction equal to 0 when the numerator is equal to 0 and the denominator not equal to 0. Numerator is 2x square plus 2y square minus 2x minus iy equal to 0. The denominator of course not equal to 0. For two reasons. One, it's the sum of two squares, and second reason, z not equal to 1. So it's always not equal to 0. So for the set of points m, any equation that starts with x squared plus y squared might be a circle, but this equation starts with 2x squared plus 2y squared. So we have to divide it by 2. X squared plus y squared minus x minus half y equal to 0. Now this equation can be maybe the equation of a circle. On a graph paper we'll say minus 2a equal coefficient of x minus 1, so a equal half. Minus 2b equal coefficient of y minus half, so b equal 1 over 4. So the coordinates of the center I equal half 1 over 4. I will try to solve r square equal a square plus b square minus c equal 1 over 4 plus 1 over 16 minus c, the constant number here is 0, is equal minus 0, and the answer is over 16 for 5 over 16. Okay, so we found the r square is a positive number, so of course it's a circle. So in this case m moves on the circle C, on the circle C of center I half 1 over 4, and radius r equal radical of this answer, radical of 5, radical 16 is 4, radical of 5 over 4. But you have to remember that z not equal to 1. Okay, and if you did replace 1 in the equation, you will obtain its belongs to, so deprived of the point a1 0. Why is deprived of the point a1 0? Because z not equal to 1. Okay, 1 is represented by the point 1 0, and 1 0 belongs to this circle, so it should be deprived from it. Part B. Z prime pure imaginary. Z prime pure imaginary. We have two conditions: real part of z prime equal to 0 and imaginary part of z prime not equal to 0. Real part of z prime هون yeah, a real part of z prime equal to 0. This fraction is equal to 0 when the numerator equal to 0. So 2y plus x minus 1 equal to 0, and imaginary part not equal to 0. Imaginary part, a fraction not equal to 0, when 2x squared plus 2y squared minus 2x minus 1 equal to 0. This is the equation of a straight line, and this is the equation of a circle that we found its center and radius. So I will say that z will move on this line. 1 minute bus. So I will say that z moves on this line deprived of the point of intersection with this circle, but I need to find the points of intersection. So on a draft paper I have to solve 2x squared plus 2y squared minus 2x minus y equal to 0, and this equation can be written as 2y, or let's say x equal 1 minus 2y, or I can find y in terms of x, and we should replace x in the first equation. So we'll obtain 2 into 1 minus 2y squared plus 2y squared minus 2 into 1 minus 2y minus y equal to 0. 2 into 1 minus 4y plus 4y squared plus 2y squared minus 2 plus 4y minus y equal to 0. 8y squared plus 2y 10y squared minus 8y plus 4y minus 8y plus 4y minus 4y minus y minus 5y plus 2 minus 2 is 0. We obtain a quadratic equation. The solution are y1 equal to 0 and y2 equal 5 over 10 half. So x, replace y by 0 in this equation number 2, you obtain x equal to 1. This is the point that we call this a10, and another, in this case x equal, replace x by half. 1 minus 2 times half is 0. So this is another point b0 half. These are the points of the intersection of this line with this circle. The line must be on this line but not on this circle. So these are the deprived points. So in this case M moves on the straight line D, of equation 2y plus x minus 1 equal to 0, deprived of the points a10 and b0 half. But you have to say that a or z not equal to 1. So of course deprived of the point 10, and it's being written here, so you don't have to write it again. This was the exercise number 4. Finally, exercise number 5 is very easy. Number 4 actually is the most important exercise in this worksheet. Solar system. The complex plane is referred to the system OUV. This is O and this is U, the unit vector of the x-axis, and this is V, the unit y vector of the xy-axis. Consider the point A, ZA equal 5i, so A0, 5. 1, 2, 3, 4, 5. This is A platform. This is the point A0, 5. And z let b equal 5, so the point B of coordinates 5, 0. This is the point B. Plot A and B we did. Plot A prime and B prime such that ZA prime equal ZA bar. ZA bar is minus 5i, so A prime will be 0 minus 5. We also know that Z and Z bar are always symmetric with respect to the with respect to the x-axis. So this is A prime, minus 1, minus 2, minus 3, minus 4, minus 5. This is A prime. is A prime, and ZB prime equals ZB bar. The bar of 5 is the same, so B prime will be 5 0 as the same, because ZB bar of 5 is 5, so B prime will be in the same position as B. This is everything. Thank you for listening. I'll see you. Bye.